a vast, silent void between stars where nothing happens and nothing exists. Voyager showed us that this picture is deeply incomplete. Interstellar space is thin, yes. The number of particles per cubic centimetre is extraordinarily low compared to anything we experience on Earth. But thin does not mean empty, and it certainly does not mean inactive. The interstellar medium is filled with matter, energy and structure. It contains gas atoms, both neutral and charged. It contains dust grains, tiny solid particles made of carbon, silicates, and ice. It contains magnetic fields that stretch across enormous distances, and it contains radiation from countless sources near and far. Voyager's instruments began detecting this environment directly after crossing the Heliopause. For the first time, measurements were no longer filtered through the sun's protective bubble. The spacecraft was sampling the raw material of the galaxy. One of the most noticeable changes involved cosmic rays. These are high-energy particles, mostly protons and atomic nuclei, that travel through space at nearly the speed of light. Many are born in violent events such as supernova explosions, where stars end their lives in massive outbursts of energy. Inside the heliosphere, the solar wind deflects and modulates a significant portion of these particles. Outside, that shielding weakens dramatically. Voyager detected a sustained increase in cosmic ray intensity, confirming that it had entered a region where galactic influences dominated. These particles carry information about distant events, sometimes thousands of light-years away. In interstellar space, Voyager was bathing in the galaxy's history. This alone challenges the idea that interstellar space is quiet. It is filled with signals from across the Milky Way, constantly passing through. Another important change involved plasma density. Plasma is a state of matter where electrons are separated from atomic nuclei, creating a soup of charged particles. Inside the heliosphere, most plasma originates from the Sun. Outside, it comes from the interstellar medium. Voyager's instruments measured an increase in plasma density that could not be explained by solar sources. This provided further confirmation that the spacecraft was now in a new environment. What is striking about these measurements is how subtle the transition was. There was no sudden surge, no sharp boundary. Instead, values shifted gradually and then stabilized at new levels. Interstellar space does not announce itself. It simply behaves differently. Magnetic fields also told an important part of the story. The sun's magnetic field is carried outward by the solar wind, twisted into a spiral pattern by the sun's rotation. This creates a distinct magnetic signature inside the heliosphere. Beyond the Heliopause, Voyager detected magnetic fields that were no longer dominated by this solar pattern. Instead, they reflected the broader galactic field, shaped by processes occurring on scales far larger than our solar system. These fields are weak by everyday standards, but they exert influence over enormous distances. They guide the motion of charged particles. They shape the structure of interstellar clouds. They connect regions of the galaxy that would otherwise seem isolated. Voyager's entry into this magnetic environment marked another sense in which interstellar became real. The spacecraft was now embedded in the Milky Way's own fabric. It is worth pausing here to appreciate how unfamiliar this environment is to us. Every human being who has ever lived has existed inside the heliosphere. Even our most distant probes, until Voyager, remained under the sun's direct influence. Our understanding of space has always been solar-centered, even when we study distant stars. Voyager changed that by stepping outside the sun's immediate domain and letting the galaxy take over. This shift in perspective is one of the most profound aspects of the mission, and it is easy to miss because nothing dramatic accompanies it. When we hear interstellar, we often imagine a spacecraft travelling between stars, moving from one stellar system to another. Voyager is not doing that. It is not headed toward a specific star. It is drifting through the space between stars, and that space is far larger than most people realise. The distance between stars in our region of the galaxy is measured in light years. Even travelling at Voyager's remarkable speed, it would take tens of thousands of years to approach another star closely. Interstellar space, then, is not a corridor you pass through quickly. It is the dominant environment of the galaxy. Most of the Milky Way's volume consists of interstellar space. Stars, planets, and solar systems occupy a tiny fraction of it. Voyager has entered the majority domain. This realization reframes scale in a fundamental way. The solar system, once imagined as a large structure, becomes a small bubble within an ocean that stretches across tens of thousands of light years. Interstellar space also has structure. It is not uniform. There are regions of higher density and lower density. Clouds of gas and dust form and disperse. Shock waves from supernovae propagate through it. Star formation begins in dense pockets, where gravity overcomes pressure. Voyager is currently travelling through a relatively calm region known as the local interstellar cloud. This cloud is part of a larger complex of interstellar material that the Sun happens to be moving through at this point in its galactic orbit. This means that interstellar conditions are not fixed. As the Sun moves around the Milky Way, it passes through different regions of interstellar space, each with its own density, temperature, and magnetic properties. Over millions of years, the heliosphere itself changes shape in response to these environments. It expands in some regions and compresses in others. The size of the solar system, defined by the Sun's influence, is not constant over geological time. Voyager's measurements provide a snapshot of this interaction at a particular moment in the Sun's journey through the galaxy. Another misconception about interstellar space is that it is timeless, that nothing changes. In reality, interstellar space evolves constantly, just on timescales that dwarf human experience. Gas clouds collapse to form stars. Stars explode and seed space with heavy elements. Magnetic fields twist and reconnect. Radiation permeates everything. Voyager is moving through this environment, sampling it slowly, steadily, without urgency. Its instruments detect changes over years rather than seconds. Subtle trends matter more than dramatic events. Communication delays now stretch close to a full day. When Voyager sends data, it describes conditions that existed many hours earlier. Earth receives those descriptions long after the spacecraft has moved on. This delay adds another layer to what interstellar means. It is not just physical distance, it is temporal separation. Cause and effect are stretched across time in ways that feel unfamiliar. From Earth, we often think of space exploration as something that happens in near real time. Images arrive quickly, commands are executed promptly. Voyager's interstellar journey makes that impossible. Operations become predictive rather than reactive. Engineers plan far ahead. They trust models. They wait. That waiting is part of the interstellar experience. Voyager's power supply continues to weaken as radioactive fuel decays. Instruments are shut down gradually to conserve energy. Each year, the spacecraft becomes simpler, quieter, more focused. This simplicity suits interstellar space. There is no need for cameras, no planets to image. What matters now are particles, fields, and long-term trends. The spacecraft has become a sensor more than a visitor. As Voyager continues, it will eventually lose the ability to communicate. Its signal will fade below detectability. At that point, it will become a silent object drifting through the galaxy. Even then, it will still be interstellar. It will still move between stars. It will still carry its golden record, its message, and the physical evidence of a civilization that once reached outward. Interstellar then does not mean gone. It does not mean finished. It means no longer defined by one star. This distinction is crucial for understanding the true scale of the solar system. If interstellar space begins only after travelling a distance many times greater than the planetary system, then the solar system itself is far larger than the diagrams suggest. The planets occupy the inner core. The heliosphere extends far beyond them. The heliosheath adds another enormous layer. And only after all of that does interstellar space begin. Even then, the Sun's gravitational influence persists. So where does the solar system truly end? The answer depends on what you mean by end. If you mean where planets stop, that happened long ago. If you mean where the Sun's plasma influence ends, that occurs at the Heliopause. If you mean where gravity stops mattering, that lies far beyond anything Voyager will reach. Interstellar space is not the absence of the solar system. It is the context in which the solar system exists. Voyager's entry into this context has reshaped how we think about our cosmic neighbourhood. It has shown us that most of the space associated with our star is invisible, intangible, and easy to ignore, yet profoundly important. For listeners resting now, letting the ideas unfold without needing to hold them tightly, it may help to think of interstellar space not as a void, but as a quiet background presence. a medium through which stars move, a reservoir of material from which new stars and planets will one day form. Voyager is part of that background now. The spacecraft continues to drift, still sending data as long as it can, still measuring the galactic environment directly. Each bit of information adds to our understanding of what lies between stars. This understanding does not come in bursts. It arrives slowly. It accumulates. And that is perhaps the most honest reflection of what Interstellar actually means. It is not a dramatic leap into the unknown. It is a gradual immersion into a larger environment, one that was always there, surrounding us, shaping us, even when we could not feel it. Interstellar is not an edge crossed. It is a condition entered. At a certain distance, the familiar tools we use to describe space begin to feel inadequate. Not because they are wrong, but because they stop helping us imagine what is actually happening. Voyager reached that point long ago, long before it crossed into interstellar space, long before the Sun became just another star. The numbers used to track its journey started to lose their emotional meaning. Kilometers were the first to fail. In the early days of spaceflight, kilometers and miles still felt usable. Earth to the Moon, Earth to Mars, even Earth to Jupiter, while enormous, could still be framed as a very large version of something we understood. We could say hundreds of millions of kilometers and feel a sense of awe that was at least anchored to something familiar. But as Voyager continued outward, those numbers multiplied too quickly. Millions became billions, billions stacked on top of each other. The figures grew so large that they no longer produced a stronger sense of distance. They flattened into abstraction. Saying that Voyager is tens of billions of kilometers away does not feel 10 times more distant than saying it is 1 billion kilometers away. To the human mind, both are simply very far. This is where measurement and understanding begin to diverge. Scientists anticipated this problem long before Voyager launched, which is why astronomy relies on alternative units designed to scale with space rather than with human experience. The astronomical unit, or AU, defined as the average distance between Earth and the Sun, became the first step away from everyday measurement. One astronomical unit feels reasonable, Earth to Sun, a distance we already accept as fundamental. When Voyager passed Jupiter at about 5 astronomical units, Saturn at roughly 10, Uranus near 20, and Neptune around 30, those numbers still carried some structure. They built on each other. They suggested a widening system, but even astronomical units eventually began to fail. As Voyager moved beyond the planets, AU values climbed steadily. 50, 100, 150. Each increase represented enormous distance, yet the numbers themselves stopped evoking anything tangible. This is not a failure of math. It is a limitation of perception. Our brains evolved to handle distances relevant to survival. Walking, running, seeing across a field, even travelling across oceans required centuries of adaptation and technology. Space operates on scales that were never meant to feel intuitive. Voyager exposed that mismatch. To cope, astronomers introduced time-based units, light seconds, light minutes, light hours. These units translate distance into delay, something we experience directly. A light second is about the distance light travels in 1 second. Earth to Moon is roughly 1¼ light seconds. Earth to Sun is about 8 light minutes. Already this reframes space as time. By the time Voyager was deep into the outer solar system, its distance was measured in light hours. Signals sent from Earth took half a day or more to arrive. Replies took just as long to return. This delay is not theoretical. It shapes every interaction with the spacecraft. When engineers send a command to Voyager, they are speaking to the past. When they receive data, they are hearing an echo of a moment that no longer exists. There is no shared now. Light hours feel more meaningful than kilometers because they tie distance to waiting. They make separation experiential. Still, even light hours have limits. As Voyager moved farther into interstellar space, light days became relevant. Then light weeks, conceptually, though not yet in practice for Voyager itself. Beyond that, light years dominate the language of astronomy. A light year is not a time, it is a distance. The distance light travels in 1 year, nearly 10 trillion kilometers. That number is so large it is functionally meaningless on its own. So astronomers use light years not because they are intuitive, but because they are scalable. They allow comparison. They let us say that one star is 4 light-years away, another is 100, another is thousands. Voyager brings this scaling problem into sharp focus because it occupies an awkward middle ground. It is far beyond anything humans have visited before, yet still incredibly close compared to the distances between stars. This creates a strange cognitive tension. Voyager feels impossibly far, yet it has not even begun a true interstellar journey in terms of stellar separation. It has crossed the sun's boundary, but it has barely dipped its toe into the galaxy's vast interior. At Voyager's current speed, reaching the nearest star would take tens of thousands of years, and that star, Proxima Centauri, is only about 4 light-years away. Many stars in the Milky Way are hundreds or thousands of light-years distant. This reveals something deeply unsettling about scale. The solar system, which already feels unimaginably large, is still tiny compared to the space between stars. Voyager helps us feel this by existing in between categories. It is not near. It is not meaningfully far in galactic terms. It simply continues. Another way scientists try to bridge this gap is through analogy, shrinking the solar system down to something familiar: a football field, a grain of sand, a city map. These analogies are helpful, but they have limits. If the sun were the size of a grapefruit, Earth would be a tiny speck several meters away. Neptune would be hundreds of meters distant. The Heliopause would lie kilometers away. And the nearest star would be thousands of kilometers from that grapefruit. At that scale, Voyager would still be travelling between neighbourhoods, with nothing but empty land in between. Analogies reveal something numbers often hide. Space is not just big, it is empty. The emptiness is not absolute. There are particles, fields, radiation, but there is nothing to look at, nothing to orient by, no surfaces, no landmarks. Voyager crossed billions of kilometres where nothing happened that could be photographed. Nothing happened that would feel like progress to a human traveller. This is another sense in which numbers fail. Distance implies motion toward something. But most of Voyager's journey is motion through nothing in particular. The spacecraft does not move from one object to the next. It moves through regions defined by changing influence, not by location. This makes traditional distance measures feel unsatisfying. They tell you how far, but not what that means. What matters more in Voyager's story is not the absolute distance from the Sun, but how the environment changes with distance. Sunlight fades, solar particles weaken, galactic particles grow stronger, magnetic fields shift, power declines, communication delays lengthen. These changes give distance texture. Instead of asking, how far is Voyager, a more meaningful question becomes, what does space feel like where Voyager is now? And that question cannot be answered with kilometres. Voyager has shown us that distance in space is experienced as transition rather than separation. It is not about leaving one place and arriving at another. It is about moving through gradients. This is why defining the solar system's size is so difficult. If you define it by planets, you get one number. If you define it by the heliopause, you get a much larger one. If you define it by gravitational influence, the number grows again. Each definition is correct within its own context. Numbers fail when we expect them to deliver meaning on their own. Another subtle way distance manifests is through energy. Every system on board Voyager must account for the increasing cost of communication. Transmitting a signal across greater distance requires precise pointing and careful use of limited power. Voyager's transmitter sends a signal that spreads outward at the speed of light, thinning as it goes. By the time it reaches Earth, that signal is unimaginably faint. Detecting it requires antennas the size of buildings, coordinated across continents. Even then, the signal must be extracted from background noise. Distance here is not just how far something travels, it is how much it disperses along the way. This dispersion mirrors how influence fades with distance. The sun's light, the sun's wind, Voyager's signal, all weaken not because something blocks them, but because space allows them to spread. This spreading is gentle, relentless, and indifferent. Voyager also reveals distance through delay in decision-making. Engineers must anticipate problems far in advance. They cannot react quickly. They must trust that sequences sent today will make sense tomorrow, next week, next year. This changes the relationship between human intention and machine action. Near-Earth space missions feel interactive. Commands are sent, responses are received, adjustments are made. Far from Earth, that feedback loop stretches until it barely feels like a loop at all. Voyager operates with a kind of autonomy enforced by distance. This autonomy is not intelligence, it is inertia. The spacecraft continues doing what it was last told to do, long after the people who gave those instructions have gone home, retired, or passed away. Distance here becomes generational. Many of the engineers who designed Voyager are no longer alive. The spacecraft outlasts them. It carries their decisions forward into a future they never saw. Numbers cannot capture that. This is another way measuring distance fails. It does not account for human timescales. It does not reflect how far something travels relative to a lifetime. Voyager's journey spans generations. That alone places it outside intuitive measurement. As the spacecraft continues into interstellar space, new distance scales will become relevant. Not in practical terms, but conceptually. Tens of thousands of years, millions of years, galactic orbits measured in hundreds of millions of years. At those scales, distance and time blur together completely. The solar system itself orbits the centre of the Milky Way once every 200 million years or so. Voyager will complete that orbit alongside the Sun, drifting quietly, long after Earth's continents have reshaped themselves. At that scale, the distinction between far and near dissolves. Voyager is not going somewhere specific. It is participating in a motion shared by everything bound to the galaxy. This perspective is uncomfortable because it removes destinations. It replaces goals with trajectories. Numbers like kilometres, astronomical units, and light years are excellent tools for calculation. They are necessary. But Voyager shows us that they are insufficient for understanding. Understanding requires context. The true scale of the solar system is not something you grasp by memorising distances. It's something you feel by recognising how long transitions take, how gradually influence fades, how little happens across enormous spans. Voyager's slow progress forces us to confront the difference between movement and arrival. Even now, decades after launch, the spacecraft is still leaving, still transitioning, still moving through layers of influence that refuse to compress into a single value. For listeners resting and letting these ideas drift, there is a quiet relief in this realization. You do not need to hold the numbers. You do not need to remember distances. It is enough to know that the solar system is not small, that its true size lies mostly beyond the planets, that the space between stars is vaster still. Voyager teaches this not by declaration, but by example. By existing so far away that our usual measurements lose their grip, the spacecraft invites us to accept that some scales cannot be made comfortable. Distance at this level is not something to count, it is something to respect. And as Voyager continues onward, still measurable, still trackable, but increasingly removed from anything familiar, it carries with it a final lesson about distance, that when numbers fail, patience remains. The solar system's true scale is revealed not in units, but in years without arrival, in signals delayed by days, in transitions that take lifetimes to cross. Picture this not as a thought experiment meant to impress, but as a practical way to steady the mind when numbers stop helping. Shrink Earth down until it is no larger than a single grain of sand resting on your fingertip. Not a poetic grain, not a symbolic one, just an ordinary dry grain you might brush off a table without noticing. Now stop there for a moment, because this is where scale usually slips away. That grain of sand represents everything familiar, every ocean, every city, every memory, every moment of human history. All of it compressed into something so small that a breath could move it. This is not meant to diminish Earth, but to anchor it, to give it a size the mind can actually hold. Once that scale is set, everything else has to follow the same rules. If Earth is a grain of sand, the moon is not right next to it. It sits several centimetres away. Already, this surprises most people. We tend to imagine the moon as close, almost attached. On this scale, there is empty space you could easily see between them. The sun, on this same scale, is no longer nearby either. It becomes a sphere roughly the size of a large beach ball, placed about 15 metres away from that grain of sand, not across the room, not just outside the door, far enough that you would have to walk to reach it. That distance, 15 metres, is the Earth-Sun distance, one astronomical unit. And even at this reduced scale, it is already larger than intuition expects. Now let's keep going, because this is where Voyager's journey really begins to matter. Mars, still small, sits several meters beyond Earth. The inner planets occupy a region you could walk across in seconds. Even here, they feel more spread out than the diagrams suggest. Then comes the long, quiet stretch toward Jupiter. On this scale, Jupiter is not just farther out. It is far enough away that Earth's entire neighbourhood feels compact by comparison. Jupiter becomes another small object, larger than Earth's grain but still modest in size, positioned nearly 80 meters from the Sun. That is almost the length of a football field. Between the Sun and Jupiter, there is nothing, just empty space. This emptiness is not a gap you skip over, it is the majority of the journey. Saturn sits roughly twice that distance from the Sun. Uranus and Neptune push the scale outward even further, hundreds of meters from where that grain of sand began. By the time you reach Neptune, you're standing several hundred meters away from your starting point, with nothing but open space behind you. And this is where most diagrams stop. On paper, Neptune often appears near the edge of the solar system, as if it marks some kind of boundary. On the grain of sand scale, Neptune is simply another small marker along a path that keeps going. Far beyond Neptune, the planets are finished, but the solar system is not. The Kuiper Belt, a region of icy objects, stretches farther still.
On this scale, it occupies distances measured in kilometers, not steps, not fields, kilometers. Even then, the Sun's influence continues. Now place the Heliopause, the region where the Sun's solar wind finally gives way to the interstellar medium. On this scale, it is not just beyond the planets, it is several kilometers away from the beach ball Sun. Let that settle. If Earth were a grain of sand, the true boundary of the Sun's influence would be so far away that you would need to travel by car to reach it. Voyager crossed that distance, not quickly, not dramatically, it took decades. This analogy does not exaggerate anything. If anything, it simplifies. It gives you something solid to hold on to when astronomical units and light hours stop meaning anything emotionally. The real lesson here is not how far Voyager went, but how much space there is between everything. Most of the solar system's volume is not occupied by planets. It is not occupied by objects at all. It is occupied by space shaped gently by the Sun's influence. Voyager spent years crossing regions where nothing visually changed, because on this scale, nothing is supposed to. When Voyager left Earth, it did not leap from one landmark to the next. It entered an environment defined by absence, long stretches where the only meaningful change was distance itself. On the grain of sand scale, Voyager's entire planetary tour occupies a surprisingly small region. The inner solar system fits within a few dozen meters.
The giant planets stretch it to a few hundred. Everything that revealed the true scale came afterward. From Neptune to the termination shock, from the termination shock through the heliosheath, and finally to the heliopause, Voyager crossed distances that dwarf the planetary system. This is where the illusion of closeness collapses completely. When people hear that Voyager has left the solar system, they often imagine it slipping just beyond the last planet as if stepping over a line. The grain of sand scale shows how misleading that image is. Voyager did not step out of the solar system. It walked steadily for kilometers, and even now it has only just begun to experience interstellar space. On this scale, the nearest star is unimaginably far away. If the Sun is a beach ball, the closest neighbouring star would be another beach ball located thousands of kilometres away. Not across the city, not across the country, far beyond anything you would casually reference. Voyager is nowhere near that next star. This is important, because it reframes what interstellar actually implies. Voyager is between stars, yes, but between does not mean halfway. It means entering a space that is mostly nothing for a very long time. The grain of sand analogy also helps explain why Voyager's signal is so faint. Radio waves spread outward, thinning as they go, just like sunlight. By the time Voyager's signal reaches Earth, it has spread across an area so vast that only a tiny fraction is intercepted by our antennas. On this scale, Earth's receiving dishes are smaller than dust. Listening to Voyager is an act of precision and patience. Another thing this analogy reveals is why travel between stars is not a matter of building slightly faster rockets. Even if Voyager were 10 times faster, or 100 times faster, the scale would barely change in a way that feels meaningful. Space is not just big, it is overwhelmingly sparse. Voyager's success was never about speed, it was about endurance. If Earth were a grain of sand, Voyager would be a microscopic tag riding that grain outward, still attached to it by the faintest thread of radio light. That thread stretches across kilometres of empty space, and it still holds. This perspective also changes how we think about home. When Earth is reduced to a grain of sand, it does not feel less important. It feels more fragile, more specific, more precious. Voyager carried that grain story with it, etched into the golden record. Sounds, images, greetings, all originating from that tiny point. The vastness around it does not erase that story, it gives it context. As Voyager continues drifting deeper into interstellar space, the distances ahead become almost impossible to place on this scale at all. Tens of thousands of years of travel, millions, entire geological epochs passing as the spacecraft moves slowly through the galaxy. At that point, even the grain of sand analogy begins to strain. But it has already done its job. It has shown that the solar system is not a neat cluster of nearby worlds. It is a vast region where one star's influence slowly fades into the background of many others. It has shown that Voyager did not simply leave home. It carried home outward, across distances that cannot be rushed or simplified. And it has shown that when Earth is small enough to fit on your fingertip, the journey Voyager made becomes less about reaching somewhere else, and more about revealing just how much space there is between everything. Maps are comforting because they compress reality into something manageable. They take something too large to grasp and fold it into a page, a screen, a diagram that fits inside the boundaries of human attention. For centuries, our mental map of the solar system has worked exactly like that. A central sun, a sequence of planets, a tidy layout that can be memorized, drawn, and taught to children without overwhelming them. Voyager did not tear up that map. It quietly revealed that most of it was blank. Before Voyager, the solar system was often imagined as a planetary system with a little extra space around it. The outer planets felt like distant outposts, and beyond them lay a vague region of darkness that did not demand much thought. The focus was on the objects. The spaces between them were treated as background. Voyager forced us to redraw the proportions. When the spacecraft crossed the orbit of Neptune, it did not reach the end of anything. It entered a region that would take decades to traverse. That fact alone stretches the mental map. If the last planet sits only a small fraction of the way toward the Sun's boundary, then the planetary system occupies only the inner core of something much larger. This realization shifts emphasis from objects to influence. The old mental map centered on where planets orbit. The new one centers on how far the Sun's reach extends. That reach is not marked by solid bodies, but by particles, magnetic fields, and pressure balances that cannot be seen with the naked eye. Voyager changed our map because it travelled into those invisible regions and measured them directly. Before its journey, the heliosphere existed mostly as theory. Scientists understood that the solar wind must carve out a bubble in interstellar space. But the size and shape of that bubble were uncertain. Models varied, estimates differed. The termination shock, heliosheath, and heliopause were concepts supported by indirect evidence. Voyager transformed those concepts into measured realities. When the spacecraft crossed the termination shock, it confirmed that the solar wind does indeed slow down and heat up at a vast distance from the Sun. When it moved through the heliosheath, it revealed turbulence and complexity that simplified diagrams had missed. And when it crossed the heliopause, it provided the first direct sampling of interstellar space. Each of these steps added depth to our map. Instead of a simple circle around the planets, we now understand the solar system as a layered structure. Inner planetary region, outer planetary region, Kuiper belt, termination shock, heliosheath, heliopause. Beyond that, the interstellar medium. This layering dramatically increases the perceived size of our star's domain. Another way Voyager reshaped the mental map is through time. Before Voyager, the outer reaches of the solar system were thought of as distant but static. There was little sense of dynamic interaction beyond the planets. Voyager's data showed that the heliosphere expands and contracts with solar activity. its boundaries shift. Its shape is influenced by the sun's motion through the galaxy. This adds motion to the map. The solar system is not a fixed structure drifting passively through space. It is an active participant in a larger galactic environment. Its boundaries respond to changing conditions. Its outer regions fluctuate over years and decades. Voyager's long-term measurements were crucial here. A single crossing would have offered a snapshot. Decades of data revealed patterns. The mental map also changed in terms of perspective. For most of human history, every measurement we made of space came from inside the heliosphere. Our instruments were sheltered by the sun's protective bubble. Voyager became the first outpost outside that shelter. That fact alone forces a conceptual shift. We now have two vantage points, inside and outside. The difference between them clarifies what the sun's influence truly does. It shields us from a portion of galactic radiation. It shapes local magnetic fields. It creates a distinct plasma environment. Without Voyager, these effects would remain abstract. The spacecraft also changed how we think about leaving the solar system. The phrase sounds decisive, as if it implies a clear boundary crossed once and for all. Voyager showed that leaving is gradual. First, you leave the inner planets, then the giant planets, then the planetary region altogether, then you cross the termination shock, then you move through the heliosheath, then you reach the heliopause. Each step redefines what inside means. This layered departure replaces a simple edge with a gradient. Our mental map had to accommodate that complexity. Voyager also influenced how we think about scale relative to the galaxy. Before its journey, it was easy to imagine the solar system as a reasonably large structure within the Milky Way, large enough to feel significant. Voyager's measurements reveal that even our star's full plasma domain is tiny compared to the distances between stars. This repositions the solar system within the galaxy's hierarchy. The Sun is not at the centre of anything beyond its own immediate region. It is one star among hundreds of billions. Its bubble of influence is impressive locally, but modest in galactic terms. That perspective humbles the map without diminishing it. Another important change involves communication. As Voyager moved farther away, signal delays increased dramatically. Commands and data exchanges stretched across nearly a full day. This altered how missions are managed. It introduced a new awareness of separation. Distance stopped being just a number and became an operational constraint. This operational reality feeds back into the mental map. It reinforces that Voyager is not just far, it is far enough that interaction is fundamentally different. The spacecraft's faint signal also highlights the scale of dispersion. Radio waves spread out, thinning as they travel. Detecting Voyager requires enormous antennas and precise calibration. This sensitivity to faint signals underscores how large the space between Earth and Voyager truly is. Our map now includes not just physical distances, but communication realities. Voyager also changed how we imagine the long-term future. The spacecraft will outlive the civilization that built it. Long after its power fades and its instruments go silent, it will continue drifting through interstellar space for millions, even billions, of years. This longevity stretches the map forward in time. The solar system is not just a spatial structure. It is a temporal one. It evolves. Its boundaries shift. Its star moves through the galaxy. Voyager's journey is a thin line extending into that future. The golden record on board Voyager adds another dimension. It carries a message from a small planet orbiting a modest star. Knowing how far Voyager has travelled makes that message feel different. It is not just travelling outward. It is embedded in a scale that dwarfs it. This contrast reshapes how we see ourselves within the map. Another subtle shift involves the definition of centre. In old diagrams, the Sun sits at the centre, surrounded by planets. Voyager's journey reminds us that the solar system itself is not at the centre of anything larger. It orbits the centre of the Milky Way, along with countless other stars. This places our mental map within a broader one. The solar system is a local feature within a galactic disk tens of thousands of light-years across. The heliosphere is a small bubble within that disk. Voyager is now sampling the medium that fills most of that disk. The map keeps expanding. Voyager's success also influences how future missions are conceived. Knowing that it is possible to reach and measure the Heliopause encourages thinking beyond planetary exploration. It expands ambition. the boundary between solar system science and galactic science has blurred. Data from Voyager informs models of other stars' astrospheres. It helps scientists understand how different stars carve out their own bubbles in interstellar space. It connects our local measurements to universal processes. This interconnectedness further alters the map. The solar system becomes a case study within a broader galactic pattern. For listeners allowing this narrative to unfold calmly, the key point is not that Voyager made the solar system larger. It made it deeper. The old map showed objects. The new one shows influence. The old map suggested boundaries. The new one reveals gradients. The old map implied a tidy structure. The new one embraces complexity. Voyager did not discover new planets in its later years. It did something quieter and arguably more transformative. It filled in the blank space beyond the planets. Blank space, it turns out, is not blank. It contains structure, motion, and interaction. It contains the sun's fading influence and the galaxy's growing presence. It contains layers that cannot be seen but can be measured. By crossing those layers, Voyager gave us a more accurate sense of proportion. The solar system is vast compared to human experience. It is small compared to the galaxy. It is dynamic rather than static. It fades rather than ends. That revised map will remain even after Voyager's signal fades. Future probes may travel farther and faster. They may send richer data. But Voyager will always represent the first time we stepped outside our star's immediate influence and looked back conceptually at what we'd just left. That act of stepping outside changed the shape of the map in our minds. And as Voyager continues drifting deeper into interstellar space, still moving steadily, still bound to the sun by gravity even as it samples the galaxy directly, it carries with it the quiet proof that the true scale of the solar system is not defined by where the planets stop, but by how far a single star's influence stretches before it finally blends into the vast patient structure of the Milky Way itself. Long after the famous photograph was taken, long after its initial impact settled into textbooks and quiet reflection, Voyager's continued journey gave that image a deeper context than anyone could have anticipated at the time. The pale blue dot was never just about what Earth looked like from far away. It was about what distance does to meaning, and Voyager has spent decades extending that distance far beyond what the photograph alone could convey. When the image was captured, Earth appeared as a tiny point of light suspended in a beam of sunlight. It was humbling, emotional, and unsettling in a way that words struggled to match. Everything we know, everything we care about, reduced to a speck. That moment asked us to reconsider importance, scale, and perspective. But at the time, Voyager was still relatively close at least, compared to where it would eventually go. As the spacecraft continued outward, crossing regions that no photograph could represent, the pale blue dot transformed from a snapshot into a reference point. Not a place you could see anymore, but a concept you had to carry forward mentally. Earth did not grow smaller in Voyager's cameras. The cameras were turned off. What changed instead was our understanding of how far that dot truly was from everything else. In the early years after the photograph, it was still possible to imagine Earth as a distant object within a recognisable structure. The planets were nearby, the sun was dominant, the solar system felt like a defined neighbourhood. Voyager quietly dismantled that comfort. By the time the spacecraft crossed the orbit of Neptune, Earth was no longer just far. It was lost among distances that defied intuition, and yet it remained the origin of every signal Voyager ever sent. This is the quiet tension at the heart of the pale blue dot revisited. Earth becomes less visible, less central, less influential in physical terms, even as it remains the only reason the mission exists at all. Every bit of data Voyager transmits is still aimed back toward that dot. As Voyager moved through the termination shock, the heliosheath, and eventually the heliopause, Earth transitioned from being a place within the same environment to being a place in a different one entirely. The spacecraft crossed boundaries that Earth itself has never experienced directly. From Voyager's position, Earth exists behind layers of solar influence, buffered by fields and particles that no longer surround the spacecraft. Earth is not just distant, it is sheltered. That distinction matters. The pale blue dot was photographed from inside the sun's domain. Voyager now exists largely outside it. The photograph shows Earth isolated in darkness, but Voyager's later journey reveals that Earth is also enclosed within a protective bubble that shields it from much of the galaxy's harsher environment. Revisiting the pale blue dot with this knowledge changes its meaning. The dot is not just small, it is protected. It exists inside a rare pocket where conditions allow life to persist. That pocket is not guaranteed. It is temporary on cosmic timescales. The heliosphere itself changes as the sun moves through the galaxy, expanding and contracting in response to interstellar conditions. Earth's safety is not permanent, it is contingent. Voyager's data underscores this without ever stating it outright. As the spacecraft entered regions dominated by interstellar particles, it measured increases in cosmic radiation that Earth rarely experiences at the same intensity. These particles pass through living tissue, they alter chemistry, they break DNA. On Earth, much of this radiation is deflected or absorbed before it reaches the surface. From Voyager's perspective, that protection fades quickly with distance. The pale blue dot, then, is not just a symbol of smallness, it is a symbol of shelter. That shelter was invisible in the photograph. Voyager's later journey made it tangible. Another layer emerges when considering time. When the photograph was taken, the signal carrying that image took hours to reach Earth. That delay felt manageable, almost negligible. Today, Voyager's signals take close to a full day to arrive. The pale blue dot is now not only far away in space, but far away in time. What Voyager sees and what Earth hears are separated by nearly a full rotation of the planet. This temporal separation changes how we think about connection. The photograph captured Earth as it was in a single moment. Voyager's ongoing journey captures Earth as a place that is always already in the past relative to where the spacecraft is. There is no shared present anymore. This does not weaken the significance of the pale blue dot. It deepens it. The image becomes not just a reminder of fragility, but a marker of origin, a timestamp embedded in space. Everything Voyager measures now is measured relative to something that no longer surrounds it. That fact alone reframes the photograph. At the time the image was taken, Earth was still part of Voyager's environment. The sun's wind still enveloped both. The same magnetic bubble still contained them. Now, Earth and Voyager occupy fundamentally different environments. Earth remains inside the heliosphere. Voyager is largely outside it. The pale blue dot is no longer just far. It is on the other side of a boundary that defines what it means to belong to the solar system, and yet gravity still binds them. This is another subtle revision to the photograph's meaning. Earth and Voyager are still part of the same gravitational system. They orbit the centre of the Milky Way together. They share a long-term fate on galactic timescales. Separation, in space, is rarely absolute. Voyager's journey shows that you can be environmentally separated while still being dynamically connected. That nuance is easy to miss in a single image. The pale blue dot also gains new meaning when considered alongside the golden record Voyager carries. That record contains sounds and images from Earth, chosen to represent life on that tiny point. When the photograph was taken, the record was already aboard, but its significance has grown as Voyager has moved farther away. The farther Voyager travels, the more isolated that record becomes. It is no longer a curiosity attached to a spacecraft exploring nearby space. It is an artifact drifting through interstellar space, carrying evidence of a civilization that existed inside a small, protected bubble. The pale blue dot and the golden record are inseparable in this sense. One shows where the message came from. The other carries the message forward. Revisiting the pale blue dot with Voyager's full journey in mind shifts the focus from sentiment to structure. The photograph is often interpreted as a moral lesson. Be kind, be humble, recognize our smallness. Voyager adds a physical lesson to that moral one. Understand where you are. Understand what protects you. Understand how rare your conditions might be. Earth is not just small, it is specific. The pale blue dot exists at a precise distance from a star of a certain type, inside a bubble of charged particles of a particular size, within a region of the galaxy that happens to be relatively calm at this moment in time. Voyager's measurements show that small changes in these conditions could make a profound difference. This does not make Earth fragile in a sentimental sense. It makes Earth contextual. The pale blue dot is meaningful because of everything around it, not in spite of it. Another aspect of revisiting the photograph involves permanence. When the image was taken, Earth looked timeless, a dot against darkness, no hint of change. Voyager's continued journey reminds us that nothing about Earth's situation is static. The sun evolves, the heliosphere shifts, the galaxy moves. Over millions of years, Earth's environment will change. The pale blue dot will not always look the same, even if viewed from the same distance. Voyager's long-term perspective introduces that temporal dimension. The photograph captures Earth as it was. Voyager's journey hints at what it will become, indirectly, by showing how dynamic the surrounding space actually is. This makes the pale blue dot less of a frozen symbol and more of a moment in a long process. From the spacecraft's current position, Earth is unobservable. It cannot be distinguished from other stars. It cannot be photographed. It exists only as a remembered point. That fact alone would have been unimaginable before Voyager. Revisiting the pale blue dot now means accepting that Earth does not remain visible, even in principle, once you move far enough away. Visibility is a local privilege. This realization has consequences for how we think about exploration. If Earth disappears so completely with distance, then exploration is not about keeping Earth in view. It is about carrying Earth conceptually. Voyager carries Earth in its data protocols, its engineering decisions, its design constraints, and its record. The spacecraft does not need to see Earth to represent it. This is an important distinction. The pale blue dot photograph shows Earth as an object. Voyager's continued journey shows Earth as an origin. That shift is subtle but profound. Another layer emerges when we consider how the photograph is often used rhetorically. It is cited as evidence of insignificance, a reminder that we are tiny and therefore unimportant. Voyager complicates that message. If Earth were truly insignificant, there would be no Voyager, no spacecraft capable of leaving the sun's influence, no instruments measuring interstellar space directly, no signal travelling billions of kilometres back to a planet small enough to be invisible from where it is now. The pale blue dot is small, yes, but it is also capable. Revisiting the photograph in light of Voyager's journey reframes humility. It becomes not a dismissal of importance, but a recalibration of it. Importance is not measured by size or visibility. It is measured by consequence. Earth's consequence reaches interstellar space. The spacecraft's very existence is proof of that. As Voyager continues drifting outward, the pale blue dot becomes less of an image and more of an idea, a reference point that cannot be seen but must be remembered to make sense of the journey. The photograph asked us to look back. Voyager's later journey asks us to think forward. How long will Earth remain capable of producing something like Voyager? How long will the conditions that made it possible persist? How often do such conditions arise elsewhere? These questions are not answered by the image, but they are raised by its context. Revisiting the pale blue dot with decades of additional distance does not weaken its message, it sharpens it. The dot's small, the space around it is vast. The structures that protect it are large but temporary. The ability to reach beyond it is rare. Voyager's continued signal, arriving day after day from beyond the Heliopause, reinforces all of this quietly. It does not lecture. It does not remind us explicitly. It simply exists, far away, still connected. As you rest and let this perspective settle, it may help to think of the pale blue dot not as a conclusion, but as a starting coordinate, a place to find not by what it looks like from afar, but by what it can send outward. Voyager has shown us that the true scale of the solar system is not something you see in a photograph. It is something you understand through absence, delay, and transition. Earth's image fades. Earth's influence persists. That is the deeper meaning revealed when the pale blue dot is revisited from a place so far away that the dot itself no longer exists as an image at all, only as the quiet, undeniable origin of a journey that continues, steadily, into a galaxy vast enough to make even memory feel like a kind of signal, travelling patiently outward through space and time. Out here, time stops behaving the way it does near home. It doesn't speed up or slow down in any physical sense, but it loses the cues that once made it feel anchored. No sunrises, no sunsets, no days marked by light or shadow. For Voyager, time is no longer something that passes in cycles. It is something that stretches. Near Earth, time is stitched into routine. Hours are defined by clocks, but also by meals, sleep, work, and conversation. Even in orbit, astronauts still circle a planet that turns beneath them, offering a rhythm that can be followed. Far from all of that, Voyager exists in a place where time is measured differently, not by repetition, but by delay. One of the first ways this becomes apparent is communication. When Voyager was close to Earth, commands could be sent and responses received within minutes. Problems could be corrected quickly. Adjustments could be made almost conversationally. That relationship faded gradually as distance increased. Now, a signal sent from Earth takes many hours to reach the spacecraft. A response takes just as long to return. What feels like a simple exchange becomes a process that spans most of a day. This delay reshapes the meaning of now. When engineers speak to Voyager, they're addressing a past version of the spacecraft. When Voyager replies, it describes conditions that no longer exist. There is no shared present, only overlapping histories. This separation is not dramatic, it is procedural, but its implications are profound. Time at the edge of the solar system becomes layered. Earth exists in one moment, Voyager exists in another. The connection between them is a thin stream of radio waves carrying information forward and backward through space, always late. This lateness is not a flaw. It is the natural consequence of scale. Light itself takes time to travel. Nothing can outrun it. At these distances, even light becomes slow. For Voyager, this means that every interaction is an act of patience. Commands are bundled carefully. Instruments are scheduled well in advance. There is no improvisation, no urgency. The spacecraft simply does what it was told to do long ago, until it's told something new. This creates a strange relationship between human intention and machine action. Decisions made on Earth today will affect Voyager tomorrow, or the day after, or later still. By the time those decisions take effect, the context may have shifted slightly, conditions may have changed, but the plan proceeds anyway. Time here demands trust. Another way time behaves differently at the edge of the solar system is in how change is perceived. Near Earth, change is constant. Weather shifts. Technology evolves. News cycles turn over in hours. Our sense of time is tied to rapid variation. Far from the Sun, change is slow and subtle. Voyager moves through environments that evolve over years rather than moments. Particle densities shift gradually. Magnetic fields adjust over long periods. Trends matter more than events. A single data point means very little. Meaning emerges only through accumulation. This slow unfolding alters how progress feels. There are no milestones you can celebrate easily. No obvious markers of advancement. Voyager's journey is not punctuated by arrivals. It is defined by continuation. Years pass without anything that would feel like a headline, and yet, something is always happening. The solar wind continues to weaken. Interstellar particles continue to increase. The spacecraft continues to drift deeper into a galactic environment shaped by forces far older than our star. Time, in this context, becomes geological rather than personal. Voyager's power source reinforces this shift. The radioisotope generators that keep the spacecraft alive decay predictably and slowly. Each year, a little less power is available. Instruments are turned off one by one, not because of failure, but because of necessity. This gradual decline is measured in years and decades. It is not sudden, it is not dramatic, it is steady. Time is written into the hardware. Unlike most machines we use on Earth, Voyager was never expected to be repaired, upgraded, or refreshed. Its lifespan was defined at launch by the physics of radioactive decay. Every function it performs now exists on borrowed time. That borrowed time is generous by human standards but finite. This creates a quiet countdown that does not tick audibly. There is no clock counting down seconds. There is only a slow narrowing of capability. Yet even as systems shut down, the spacecraft remains functional, simplified, focused, alive in a minimal sense. Time here is not about urgency. It is about endurance. Another subtle change involves human perception of relevance. When Voyager launched, it was part of the present. It appeared in news broadcasts. People followed its progress. It belonged to its era. Decades later, Voyager exists almost entirely outside of everyday awareness. Its journey continues but quietly. It does not compete with faster, flashier missions closer to home, and yet its relevance has increased, not diminished. Time has given Voyager context. The spacecraft has outlasted political administrations, technological revolutions, and cultural shifts. It has remained on course while the world that built it has changed repeatedly. This longevity reframes success. Voyager was not designed to deliver quick results. It was designed to persist. Time rewards that design. At the edge of the solar system, time also becomes impersonal. Voyager does not age in the way living things do. It does not anticipate an end. It simply functions until it cannot. There is something quietly honest about that. The spacecraft does not mark anniversaries. It does not know how long it has been travelling. It does not measure time at all. Time is imposed from the outside by those who track its signal and interpret its data. For Voyager, there is only state, power level, instrument status, orientation, velocity. Time passes whether anyone is watching or not. Another way time changes involves memory. On Earth, memory is reinforced constantly. We revisit places, we see familiar faces, we recognise patterns. Voyager leaves everything behind permanently. It does not circle back. It does not revisit. Its memory of the solar system is carried only in data logs and design choices. Once Voyager passed a region, that region was gone forever. This one-way journey gives time a directional quality that feels absolute. There is no return path, no chance to compare past and present directly. The only record of where Voyager has been exists on Earth, in stored data and human interpretation. Time, for Voyager, is irreversible. This irreversibility mirrors the larger structure of space itself. Stars form and evolve, galaxies change shape. Nothing returns to its original state. Voyager participates in that flow. The edge of the solar system is not just a spatial boundary, it is a temporal one. Crossing it marks a shift from human-centered time to cosmic time. Human time is measured in years and generations. Cosmic time is measured in millions and billions of years. Voyager now exists firmly in the latter domain. Consider this gently. Voyager will continue travelling long after Earth's continents have shifted, long after languages have changed, long after current technologies have been forgotten. If nothing interferes, it will orbit the centre of the Milky Way alongside the Sun for billions of years. That timescale dwarfs everything we usually care about. And yet, Voyager's journey remains meaningful precisely because it bridges these scales. It began as a human project, conceived within a specific historical moment. It now unfolds within a cosmic one. Time at the edge of the solar system stretches that bridge. Another aspect of time here involves causality. Near Earth, cause and effect feel immediate. Push a button, see a result. Speak a word, hear a reply. Far from Earth, causality is delayed. Actions ripple outwards slowly. Effects arrive long after intentions. This delay forces humility. It reminds us that control diminishes with distance, influence spreads and thins. Voyager's operators must accept that they cannot micromanage the spacecraft. They must let go. That letting go is built into the experience of time at this distance. The spacecraft itself embodies patience. It does not rush. It does not hesitate. It moves at a constant speed relative to the Sun, carrying momentum imparted decades ago. Its present is defined by past actions. This is another way time behaves differently here. The present is largely predetermined. Voyager's trajectory cannot be meaningfully altered. Its destination is not chosen day by day. Time, in this sense, feels pre-written. For listeners allowing these ideas to settle slowly, there is something calming in this realization. Not everything needs constant intervention. Not every process needs to be optimized. Some journeys unfold best when allowed to continue. Voyager's experience at the edge of the solar system suggests that time, when stretched enough, becomes less about urgency and more about consistency. It rewards systems that are simple, resilient, and patient. The spacecraft's continued operation, decades after launch, is not a triumph of speed or power. It is a triumph of time management at a cosmic scale. Eventually Voyager's signal will fade. There will be a last transmission, a final confirmation that the spacecraft is still alive, and then silence. That silence will not mean the end of the journey. Voyager will continue moving, time will continue passing. The only thing that will change is our ability to listen. This eventual silence adds another layer to time at the edge of the solar system. It reminds us that observation is temporary. Existence is not. Voyager does not need to be heard to continue. As you rest now, letting the story move at an unhurried pace, it may help to imagine time not as something rushing forward, but as something expanding outward, just like Voyager itself. Near Earth, time feels crowded. Schedules overlap, moments compete. Far away, time opens up. It becomes wide and patient. Voyager exists within that wide time now. It carries the imprint of a moment when humans decided to send something beyond the planets, without knowing how long it would last or what it would reveal. Decades later, that decision is still unfolding. Time at the edge of the solar system is not about counting hours. It is about allowing processes to run their course. Voyager teaches this by example. It does not hurry toward the future. It drifts into it steadily, carrying the past with it, as it continues into a region where time is no longer marked by clocks or calendars, but by how slowly the environment changes and how long a single, patient signal can continue to cross the vastness between a small planet and the space beyond its star. Eventually, without drama and without warning, the steady conversation will begin to thin, not all at once, and not in a way that can be pointed to on a calendar, but gradually, as one small capability after another fades. This is the quiet future Voyager has always carried within it, a future defined not by failure, but by depletion. From the moment Voyager left Earth, silence was built into the design. The spacecraft was never meant to shout forever. It was meant to speak for as long as physics allowed, and then stop. What makes this silence slow is not uncertainty. Engineers know exactly why it will happen. They can predict the cause years in advance. Voyager's power comes from radioactive decay, and radioactive decay does not negotiate. It follows its own timeline, indifferent to achievement or distance. Each year, the power available to Voyager decreases by a small but measurable amount. There is no sudden drop, no cliff, just a steady decline. With less power, fewer systems can remain active. With fewer systems, the spacecraft becomes simpler. This simplification has been happening for decades already. Cameras were among the first systems to be turned off. Once the planetary encounters ended, there was no reason to keep imaging equipment active. It consumed power, generated heat, and served no purpose in the dark reaches beyond the planets. Other instruments followed over the years, some that studied planetary magnetospheres, others that measured energetic particles no longer central to the mission. Each shutdown was deliberate, discussed, and accepted. Nothing was lost unexpectedly. Nothing failed suddenly. Voyager was never allowed to waste energy. What remains now are the instruments most essential to understanding the environment beyond the sun's influence. Plasma detectors, particle sensors, magnetic field instruments, systems that can operate quietly and continuously, extracting meaning from an environment where change is subtle. Even these will not last forever. As power continues to fade, choices will become narrower. At some point, there will not be enough energy to keep heaters running for certain components. Temperatures will drop below operational limits. Instruments will fall silent not because they are broken, but because the environment has become too cold for them to function. This is a different kind of ending than we are used to. On Earth, machines tend to fail abruptly. A component breaks, a system crashes. Something stops working from one moment to the next. Voyager's silence will not arrive that way. Instead, it will recede. There will be a final year when one instrument is turned off, then another, then another. Each year, the spacecraft will know less about its surroundings, not because the surroundings have changed, but because Voyager no longer has the energy to listen. The signal itself will grow weaker too, not because the transmitter loses strength suddenly, but because maintaining that signal requires energy for pointing, stabilization, and amplification. Eventually, even transmitting a basic carrier signal will demand more power than Voyager can provide. At that point, Earth will still be listening. The antennas will still be pointed toward the region of sky where Voyager should be. Engineers will still schedule listening windows, software will still search for patterns in the noise, and then one day, Nothing recognizable will come back. No error message, no final word, just absence. This absence will not be immediately obvious. There will be doubt. Was it a temporary glitch, a misalignment, a missed window? The listening will continue, cautiously, patiently. Only after repeated silence will the conclusion settle in. Voyager has gone quiet. It is important to understand what that silence means and what it does not. It does not mean Voyager has stopped moving. It does not mean it has broken apart. It does not mean it has reached an end. It means only that the last thread connecting it to Earth has finally grown too thin to hold. The spacecraft will continue on the same trajectory at the same speed, carrying the same mass, the same record, the same structure. It will continue to orbit the centre of the Milky Way alongside the Sun, completing a galactic orbit every few 100 million years. It will simply do so without speaking. This is why the silence ahead is slow. It does not mark a dramatic conclusion. It marks a shift in relationship. Up until that moment, Voyager exists as both an object and a conversation. Afterward, it exists only as an object. For human observers, that feels like loss. For the universe, nothing changes. There is something deeply honest about that asymmetry. Voyager's silence will not be the result of neglect. It will be the result of endurance. The spacecraft will have used its power exactly as intended, for far longer than originally required. When Voyager launched, no one expected it to operate for decades. The primary mission was planetary exploration. Everything beyond that was a bonus. That bonus turned into a lifetime. This extended life came with responsibility. Engineers became caretakers of the machine that would outlast their careers, and in many cases, their lives. Decisions made early on affected how long Voyager could keep going. Every power-saving choice extended the future slightly. Every unnecessary action would have shortened it. The slow silence ahead is therefore also a record of restraint. As Voyager's voice fades, something else becomes clearer. The mission was never about continuous presence. It was about extending human reach as far as possible, for as long as possible, and then letting go. This is a difficult idea to accept in a culture that values constant output and immediate feedback. Voyager does not fit that pattern. It produces meaning over decades, then withdraws. The silence ahead also forces us to confront how we define success. If success requires constant communication, Voyager will eventually fail. If success is defined by how far influence extends, then Voyager has already succeeded beyond any reasonable expectation. The spacecraft has changed how we understand the solar system. It has reshaped our mental maps. It has provided the first direct measurements of interstellar space. None of that is undone when the signal stops. Silence does not erase impact. Another subtle aspect of this future silence is that it will arrive unevenly. Voyager 1 and Voyager 2 will not fall silent at the same time. Their power levels differ. Their instrument usage histories differ. Their environments differ slightly. One may continue speaking after the other has already gone quiet. For a time, one voice will remain while the other is gone. This staggered silence reinforces the idea that there is no single ending moment. There is only gradual quiet. The final instrument shutdown will not be announced to the public with urgency. It will likely be noted quietly in mission logs. Perhaps a press release will mention it briefly. Perhaps it will pass almost unnoticed. By then, Voyager's presence will be largely symbolic in public consciousness. Its scientific contributions will already be complete, and yet, the emotional weight of that silence will be significant for those who have followed the mission closely. There is something uniquely human about listening across vast distances, knowing the voice on the other end is faint, delayed, and irreplaceable. The end of that conversation carries a kind of gravity that is difficult to articulate. Not grief, exactly. More like acknowledgement. Acknowledgement that something built with care, patience, and foresight has done everything it can. The slow silence ahead also reframes how we think about exploration beyond Voyager. Future probes may travel farther, they may carry more advanced instruments, they may transmit data at higher rates, but they will face the same fundamental constraints. Energy fades, distance grows, communication weakens. Silence is not a failure of design, it is an inevitability of scale. Voyager makes this clear by living long enough for us to notice. In a sense, Voyager's silence will mark the moment when the mission becomes fully complete, not because it has ended, but because it no longer requires attention. The spacecraft will no longer ask anything of Earth. It will no longer need listening time, processing power, or decision-making. It will simply exist. This transition mirrors something larger about the solar system itself. The sun's influence fades gradually. The heliosphere thins. Interstellar space takes over. There is no sharp boundary, only a slow blending.
Voyager's voice follows the same pattern. Strong at first, then quieter, then gone. The symmetry is fitting. For listeners resting now, letting this future unfold without urgency, it may help to think of silence not as absence, but as completion. The mission was never meant to be eternal. It was meant to stretch human awareness outward until physics said no more. That point is approaching, slowly and predictably, and when it arrives, Voyager will not vanish. It will simply stop announcing itself. The spacecraft will continue drifting through interstellar space, carrying the golden record, its structural integrity largely intact, its trajectory stable for millions of years. If some distant intelligence were ever to encounter it, long after Earth has changed beyond recognition, Voyager would still be there, silent but intact. That possibility is not the purpose of the mission. It is a side effect, a quiet one. More importantly, Voyager's silence will not erase what it has already told us. We will still know that the solar system is vast, that its true scale lies far beyond the planets, that the sun's influence fades gradually into the galaxy. That distance stretches time and thins connection. Those lessons do not require ongoing transmission. They are already here. The slow silence ahead also invites reflection on how we listen. Listening across billions of kilometers requires patience, humility, and acceptance that not every signal lasts forever.
Voyager has asked us to practice that kind of listening for decades. When the listening finally ends, it will not feel like a door closing. It will feel like a sound finishing its echo. For a long time afterward, we will still know where Voyager is supposed to be. We will still be able to calculate its position. We will still include it in diagrams and discussions. But the relationship will have changed. We will no longer be in conversation. We will be in remembrance. That shift is not unique to Voyager. It happens to everything that outlasts direct interaction. What makes Voyager special is that it will outlast interaction by such an enormous margin. Long after the last signal fades, Voyager will continue to move through interstellar space, crossing distances that make its entire communicative lifetime feel brief by comparison. The silence ahead is therefore not the end of the journey. It is the end of our ability to witness it directly, and that distinction matters. As the spacecraft drifts onward, it will carry with it the final evidence of a decision made on a small planet around an ordinary star. A decision to build something that would go farther than anything before it, knowing full well that it would eventually go quiet. That quiet was always part of the plan.
Long after the last signal fades into background noise, long after Earth stops listening because there is nothing left to hear, Voyager will still be moving. Not fast in any dramatic sense, and not toward anything in particular, but steadily, patiently, carried by momentum that was imparted decades ago and will not be meaningfully interrupted for millions of years. This quiet continuation is where the true scale of the solar system finally reveals itself, not as a number, not as a boundary, but as an ongoing relationship between motion, time, and influence. When we talk about Voyager drifting forever, forever does not mean endless in the way everyday language suggests. It means unconcerned with human timelines. It means unaffected by calendars, civilizations, or the lifespan of technologies. Voyager will drift for as long as the structure that holds it together remains intact. And in the environment it now occupies, there is very little to disturb it. Interstellar space is sparse. Collisions are rare. There are no atmospheres to slow the spacecraft, no gravitational traps waiting to pull it into orbit around a planet. Voyager's path is stable, governed primarily by gravity on the largest scales. That gravity still comes from the sun. This is one of the most important points to hold gently because it complicates the idea of leaving in a useful way. Voyager has left the sun's plasma environment. It has left the heliosphere. It has entered interstellar space.
And yet, it remains gravitationally bound to the Sun. The spacecraft and the Sun are still partners in a long journey around the centre of the Milky Way. Every 200 million years or so, give or take, the Sun completes one orbit around the galaxy. Voyager will complete that same orbit alongside it, slightly offset, tracing a parallel path through the galactic disk. This shared motion will continue for billions of years, unless something intervenes. That intervention is unlikely. The chance of Voyager passing close enough to another star to be significantly altered is extraordinarily small. Space between stars is vast. Even within the galaxy's crowded disk, stars are separated by light years of mostly empty space. Voyager will pass through regions of varying density, through interstellar clouds, and through magnetic environments shaped by distant stellar activity. But direct encounters are improbable. In this sense, Voyager's future is remarkably calm. It will not arrive anywhere. It will not be captured. It will not slow down in any meaningful way. It will simply continue. This is where the true scale of the solar system stops being about size and starts being about persistence. The solar system is not just a collection of objects arranged around a star. It is a moving system, embedded within a galaxy that itself is in motion. The Sun's influence extends outward not only in space, but in time, through the continued association of objects like Voyager that remain bound to it long after visible markers have been left behind. Voyager reveals this by refusing to end. Even when communication stops, the mission does not conclude in any physical sense. The spacecraft does not reach a finish line. There is no arrival state. It simply transitions from being observed to being unobserved. That transition forces a reconsideration of what scale actually means. When we say the solar system is large, we often imagine distance, how far the planets are from the Sun, how long light takes to cross those distances. Voyager adds another dimension: duration. The solar system's influence persists for extraordinarily long periods, even far beyond the regions we can easily define. Objects that originate within it continue to move with it, orbit with it, and participate in its long-term trajectory through the galaxy. Voyager is one of those objects. This means that the solar system's true scale cannot be captured by a snapshot. It must be understood as an ongoing process. The planets will continue orbiting for billions of years. The Sun will evolve, slowly growing brighter, eventually expanding into a red giant, shedding its outer layers and leaving behind a white dwarf. The heliosphere will change shape as the Sun's output changes. The surrounding interstellar environment will shift as the Sun moves through different regions of the Milky Way. Voyager will witness none of this in a conscious sense, but it will be present for much of it. That presence is what makes the phrase "drifting forever" meaningful. Forever here does not mean infinite. It means decoupled from human relevance. The spacecraft was built in a specific cultural moment. Its design reflects the technology, priorities, and assumptions of that era. And yet, its future extends so far beyond that moment that those origins become almost incidental. This contrast reveals something essential about scale. Human projects are usually judged by outcomes that arrive quickly. Success is measured in months or years. Voyager asks to be judged differently. Its significance grows with time rather than diminishing. The farther it goes, the more it reveals about the environment it travels through. The longer it lasts, the clearer it becomes that the solar system is not a compact structure with a neat ending. Instead, it is a long, tapering influence that blends gradually into the galaxy. Voyager's continued drift makes this blending impossible to ignore. When the spacecraft was near Earth, the solar system felt immediate. When it passed the planets, it felt large. When it crossed the Heliopause, it felt vast. Now, as it continues through interstellar space without destination or deadline, it feels expansive in a way that defies closure. The solar system does not end, it dissolves. This dissolution is not weakness. It is a natural consequence of how stars interact with their environments. Every star carves out a region of influence. That region has a centre where the star dominates, and edges where that dominance fades. The Sun's region happens to be large enough that a spacecraft launched from a small planet can spend decades crossing it and still not reach anything resembling an abrupt boundary. That fact alone reshapes our understanding of where we are. Earth is not near the edge of anything. It is deep inside a structure that extends far beyond our everyday awareness. Voyager's journey makes that clear by refusing to conclude. Even the golden record aboard Voyager takes on a different meaning in this context. Often discussed as a message to potential extraterrestrial finders, it is more realistically a marker of origin. The record will travel with Voyager for millions of years, through environments that no longer resemble the solar system in any obvious way. Its existence says less about communication and more about continuity. This object came from somewhere. That somewhere was not just a planet. It was an entire star system with a reach that extended far beyond the visible. Voyager embodies that reach. As the spacecraft drifts onward, it will pass through different interstellar regions. The density of particles will change. The composition of the gas will vary. Magnetic fields will shift orientation. None of these changes will be dramatic. All of them will be slow. This slowness is part of the scale. At these distances, dramatic events are rare. Change is cumulative. Meaning emerges over long spans rather than in moments. Voyager's motion is best understood as a baseline, a steady reference against which the slow evolution of the galaxy can be considered. In that sense, Voyager becomes less a spacecraft and more a trace of where the sun was, where it moved, and what it carried with it at a particular moment in cosmic history. This reframes the idea of exploration. Voyager is not exploring in the way a rover explores a planet. It is not sampling discrete locations, it is sampling continuity. By moving steadily through space that is mostly empty, it reveals how much of the universe consists of transitions rather than destinations. The true scale of the solar system emerges from this continuity. It is not just the distance from the sun to the heliopause. It is the fact that objects originating within that distance continue to matter long after they leave it. Gravity binds Voyager to the sun across interstellar space. That bond defines a scale far larger than any diagram. And yet, even gravity has limits. Over immense timescales, interactions with other stars, molecular clouds, or galactic tides could eventually alter Voyager's trajectory. The solar system itself may be reshaped by such encounters. Nothing is absolutely permanent, but these changes operate on timescales so long that they blur into the background of cosmic evolution. For now, and for a very long time to come, Voyager remains a quiet extension of the sun's story. This realization changes how we think about true scale. True scale is not just how far something reaches, it is how long its influence persists. It is how gently it fades. It is how little effort is required to maintain motion once momentum is established. Voyager reveals that the solar system's true scale includes decades of travel beyond the planets, centuries of drift beyond the heliopause, and millions of years of motion through interstellar space, all while remaining dynamically connected to its origin. That's a scale no classroom diagram can convey. It must be felt through patience. As you rest now, letting this final stretch of the story unfold without needing to resolve into a conclusion, it may help to imagine scale not as a measurement, but as a kind of quiet confidence. The confidence that things can continue without supervision, that processes can unfold without intervention. That presence does not require constant signal. Voyager will not announce its continued existence. It will not update its status. It will not mark anniversaries. It will simply be there. This is the ultimate lesson of its journey. The true scale of the solar system is revealed not when Voyager crosses a boundary, but when it keeps going afterward.
Not when it sends its last signal, but when it continues without one. Not when we stop hearing it, but when it no longer needs to be heard to remain meaningful. The solar system, viewed this way, is not a finished structure. It is an ongoing interaction between a star, its remnants in the space they move through together. Voyager is part of that interaction now. It drifts through interstellar space carrying the imprint of a small planet, a modest star, in a brief moment when curiosity outweighed caution enough to send something beyond the known. That drift will continue long after the story of its launch fades from memory, long after the last antenna stops listening, long after the idea of a mission no longer applies. And in that continued motion, the true scale is finally clear. Not compact, not contained, not defined by planets, but extended, patient and still unfolding as Voyager moves onward, not toward an ending, but deeper into a vastness where scale is measured not by how far something goes,